Okay, all the mediums are done. It's time to do the hard ones, I guess. Oh no. Let's see. Candy. There are n children standing in a line. Each child is assigned a rating given in the integer array ratings. You are giving candies to these children subjected to the following requirement. Each child must have at least one candy. Children with a higher rating get more candies than their neighbors. Okay. And then ratings 1, 2, so the output is 4 because all of them get assigned 1. Okay. With a higher rating, okay. I guess I get the problem. The question is, how am I going to figure this out? Because I can just keep looping through iteratively until both conditions are met. But then that would be so slow. Is there an easier way to do this one? Let's think. 1, 2, 2. Because the problem is, it's like if one of the ratings is higher, at the end of one array, it might trickle all the way down to the other side, where everything gets added. Because if it's like 5, 4, 3, 2, 1, 0 like this, if all of them get 1, then and then 1, 2, 3, 4, 5, something like this, it's like all of them get at least 1 first, and then you realize that 5 needs to get 1, so you do 2. And then 3 needs to get 1 more than 4, so you do 2 on that one as well. How the heck do you do this? I guess we can allocate the candies given the ratings. We can use the rating itself to determine the candies. So I guess start off at 0, return candies, and then in the middle we do for rating and ratings. Ratings, and then we can just access, well, the first rating, we need to assign it 1 candy. In a situation like 3, 2, 1, 2, 3, for example, how many candies do I need? So I need 1, 2, 3, 4, I need 5. What would the candy distribution be? 1 in the middle, these need to get 2, and these need to get 3. Okay, in a situation like this, you get 1, 1, 1. The only thing you care about are the neighbors. So perhaps this is maybe like a sliding window problem. For example, if I look at just 1, 0 to begin with, then the distribution would be 2, 1. And then as the window gets larger, or maybe as we slide the window to the next two numbers, like this. Maybe that's how we do it. Let's try just some random numbers. Okay, Excalibur. So in this situation over here, we start off with maybe first two numbers. So we determine that 5 is greater than so then our candy array for them. So every one starts off like this, comes, and then we do 2. Like this. And then in the next iteration, what we can do is we look at 1, 2. 2. So we do 2 is greater than 1, so then 2, 1, 1, 1 becomes 2, 1, 2, like this. Maybe. We keep on going. Two 72. So 72 is greater than 2. So this has to become 2, 1, 3, 3 like this, because it has to at least be greater than that. Okay, wait, maybe I see a bit of a pattern, so I can just loop through it and then we can compare. So if the previous number is greater than the current number, we can just do because everything starts off at 1, so then we can do candies plus equals to 1. We do so the previous plus equals to 1, and then we do else if current number is greater than previous number we should also, so if the current number 2 is so our algorithm can be, let's say we start off here and then we do current candies is equal to 1 because everything starts off at 1. Now we do previous candy is equal to 1. If previous number is greater than the current number, candies plus 1, and then we don't do anything. And then otherwise, equals to 1 like this. If the current number is greater than the previous number, if the current number is greater than the previous number, so we do if ratings I is greater than ratings I minus 1, because like every person needs to have at least one candy anyways. If ratings is greater than or equal to, if it's, let's do if it's less. If it's less than or equal to the current amount, previous candy equals to 1, then what we can do is we can do candies plus equals to 1 I think that would work. So for example, when we're at iteration 2, so this will be 1, 2, 1. So it goes on 1, 2, 1, and then 2, 1, 2. So when we're at iteration 2, we say, well, 2 is greater than 1. 2 is greater than 1, and if 1 has 1, which is the previous candy, has a value of 1, current value must have the current value must be a value of 1 plus equals to 1, which is 2. ratings I is less than or equal to ratings I minus. So for example here, and then no need to, no, so this is the case where the rating is bigger than, it has to be specific. If it's less than, if it's equal to, then we don't need it. So if ratings I is greater than ratings I minus 1, we still do candies plus equals to 1, but what we can do now is we can say previous, here I know we do previous candy equals to 1, previous candy has to equal to plus equals to 1 now. Also, if the ratings are equal, then there's no need to change the well, if the ratings are equal, we can do candies plus equals to previous candy minus 1, and then we can do previous candy has to just equal to, no, and we don't even need to change the previous candy in this case. Okay, let's see if this solution, if this algorithm would actually make any sense in our case. So this is our idea, and then the goal here, so let's take a look at this one here. So everything starts off at 1, this has to be 2, this also has to be 2, 72 has to be 3, oh, this can be 1, it doesn't have to be 2. So if ratings is less than, I don't even need to add anything because I would have already added it at the start, the candies plus equals to 1. If it's greater than, then we do candies plus equals to plus equals to 1, because it has to be greater than the previous value by at least 1. Really? I got 5. Okay, so 102, let's try this. What's happening over here? 102. So we start off candy, start off candy is equals to 0. No, wait, hold on, this starts off at 0, so then here we can, no, this has to start off at 1 because the previous candy at least has 1. And here we do candies plus equals to 1 because the previous value. Okay, I guess maybe let's actually try and confirm this formula works. So initially, candies equals to 1, previous candy equals to 1. So if ratings I is less than, which it is, we do candies equals to 2, and then the previous candy would have to equal to 1. Otherwise, if the ratings I is greater than how much is this? This is going to be 2, 3, 5, 8, 9, 11. Okay, so this is 11 as expected. We only got 8 for that. Why is this the case? So for 1, 2, 2, this one should just be 1 like this, which is 5, but I got 4. Okay, so let's see. We start off at index, we start off over here. We start off over here, and it says, well, the candies we have 1 so far, the previous candy is 2. If ratings I is greater than, then we do candies plus equals to 1, which gives us 3 now, and then the previous candy, which is going to be 1, plus equals to previous candy, which is going to be 2. Now over here, we do candies plus equals to 1, which gives us 4. Now if the rating is not equal, if the rating is equal, then I just need to make sure that I match the previous candy amount. Plus equals to previous candy. Oh, and then I should take previous candy. No, the previous candy doesn't change. It's still the same thing. Why does this not work? It still gives us 4. So this is just candies plus candies equals to candies plus okay, let's think about it. So here everything starts off at 1, 1, 1, 0, 0 technically. Now once we get to 2, we will add 1 to the candy, and then if ratings I, so if 2 is greater than 1, candies plus equals to 1, the previous candy and then we do prove candy has to equal to 1 plus 1, which equals to 2 at this stage. Cool. Now in the next iteration, candy plus equals to 1, and then, well, if 2 is equal to 2, we do candies plus equals the previous candy minus 1. Previous candy is 2 minus 1, which is 1. Is this not correct? Isn't this the case? Let's try another test case, I guess. What happens if they're all the same thing? If it's just 2, 2, 2, 2, and 2, what happens? Two, 2, 2, and 2 passes, but 1, 2, 2 doesn't. Is it because of the... No, this should be correct, because once you reach the end of the loop, so then what's happening? Why does this give the wrong answer? What other situations can there possibly be that's causing this to happen? I don't understand. Okay. Let's try with a different set of numbers, I guess. If this was 2, 3, 3, the same thing should occur, right? Yeah, the same thing occurs, but why is that the case? So that means my algorithm has a problem. Because if you're adding one, you should have one candy, and then after one candy, the next one you automatically add 1 to the loop. So that's going to be 2 candies. And if the rating is greater than the previous rating, which it is, because 2 is greater than 1, we add another candy, which represents this one, and then the previous candy plus equals to 1, so previous candy goes from 1 to 2 now. So now we have 3 candies in total, and previous candy is equal to 2. Okay, next iteration. Candies plus equal, so we have 4 candies now, previous candy is still 2. Now 2 is equal to 2, so we do candies plus equals to previous candy minus 1. Yes, and in this case previous candy would equal to 1, wouldn't it? If I do another one, for like the 7, two, 3, 3, 3. One, two, two. So in this case, we need. Why is the expected for this 5? Did I interpret the problem wrong then in this case? 2, 3, 3, 3, isn't it? How can it possibly be 5? Oh, okay, 1, 2, and 1. children with a higher rating, so I just don't even need this then. So if it's less than or equals 2, when the candies are equal, then can just do that. Okay. Damn it. Why is this not working now? Oh, why is there always just a f***ing case that doesn't work, mate? What's this one gonna look like? So 1, 1, 1, 1. This one goes to 2. And then we go to the next iteration, we see that, well, 3. Expected 7. Got 8. Why is this going to be... No, 1, 2, 1, 2, 1, like this. Okay, so let's see. Start off with 1 candy. Now, if ratings is greater than, we do candies plus equals to 1. So now we have 3 candies. Previous candy equals to 2. Equals to 2. Now we move on to the first number 2. We check, well, 2 is less than 3. If 2 is less than 3, if 2 is less than 3, then we don't need to add any more onto it. But then I remember this would fail for something like this, right? Plus equals to 1 for all of them. So this one will just be a bit of an anomaly, because if ratings I is less than I minus 1, we need to make sure what we add on no, and we have to just check the rating. So if I is less than ratings I minus 1, how this should work. Oh, come on, man. Oh. All the little test cases possible, why do I'm still failing so many of them? What does this one look like? This one will have to be so this will just be 3, 6, 10, 12, 13. But I get an output of 11. Oh man. So we start off at 2. Candy is equal to 1 so far. Previous candy is also equal to 1. If rating is bigger, candy plus equals to 1. So we have 3 candies. We move on to the next one. So we have plus equals to 1, so we have 4 candies. Now if this is greater, we have 5 candies now. Oh wait, I get it. So we need to add the difference. So candies plus equals 2. We gave them 2 candies, so here we need to so ordinarily this plus equals to 1. This we can't plus equals to 1 here, because that way it will just get us up to 2 candies. So we can just do candies plus equals to previous candy. Yeah. Let's try it now. 13! It's because of this thing. I am tweaking. Why does it not work? We start off at 3. 3 we move, so we iteration 1 we have 1 after that we plus so 2 candies. Previous candy has to equal to 2 since the current rating is greater than the previous rating. Move on to the next iteration, we have 3 candies, and then because we entered the first one, we do So the previous candy here would be 2. If 2 is greater than 1, then we don't. If previous candy, because the previous candy might be, let's say, 1, because then otherwise in these situations it won't work, right? Because candies, we start off at 1, next iteration, if the previous candy is equal to 1, then we need to make sure we add it on. But then in this case over here, previous candy is greater than, so we don't need to add it. Oh, come on, man. Dude, my formula is so close. Why do it just keeps failing on the dumbest things? Why the fuck is it failing? Two candies, and because the rating is greater. Oh. Why is it failing? I don't understand. Candies equals to 1, previous candy equals to 1. So we add it to equal to 2. Previous rating is greater, so candies. So we have 3 candies now, and then the previous candy is equal to 2. Now in the next iteration, we have 87, so we just plus 1 candy, so we have 4 candies, previous is 2. Now 87 is greater than that, so we need to add previous candy to it. Gives us 6. And then previous candy plus equals to 1, so it goes from 2 to 3. So 6 and 3. 6 and 3, and then we just do, so we do 7 over here, and the previous candy just equals to 1. Yeah, 7 previous candle equals to 1. Here we do 8, and it's equal to 1. And then if 2 is 8, we do 9. And previous candy equals to 1. Oh. 3 is like this, why is this... Oh, mate. 1, 2, 3, 1. So the previous candy is 1, and then at this point we have 7 candies. And the 87... Oh, it's because the 87 is not updating. Oh. Oh, that's a problem. Fine, at least I figured out the reason why it's not working. Because it's 2 updates. How the heck do you do this then? I don't know how to do this. Consider this as a valley peak problem. In each valley there should be 1 kill. Peaks and valleys. Total, because all of the children have at least 1. Higher rating than the previous child. In this case, we need to give I don't understand this one. Whatever, we'll leave it here.